Hi everybody, this is the third video lecture. We're on the page that deals with thermochemistry, which is inside the packet for chapter 15. When we talk about thermochemistry, we're talking about heat changes that occur during a chemical reaction. We think in terms of a system and its surroundings, which make up a universe. The heat that occurs during a reaction can leave a system and enter the surroundings, or the heat can leave the surroundings and enter the system. So we measure this change by enthalpy. Enthalpy is delta H, given the symbol of delta H. It's the measure of energy change that accompanies chemical and physical processes carried out at constant pressure. We have an equation, delta H for the reaction is equal to the energy of the products minus the energy of the reactants. The first reaction we're going to look at is an exothermic reaction. In an exothermic reaction, we have a process that releases heat to the surroundings. If we look at the pictures, we see obviously the one on the left is a campfire, and we know intuitively that this is an exothermic reaction, that it gives off heat. The one on the right is a little more interesting in that it shows freezing. And what happens is if a farmer feels a frost is coming, they will spray their crops with water. As the water freezes, it gives off energy. You know when ice melts, it absorbs energy. So when water freezes, it must release energy. And this energy that is released during freezing keeps the fruit warm. We can show this graphically by this following reaction. So here we have iron plus oxygen, which are the reactants, turning into iron 3 oxide, which is the product. If delta H is equal to the products minus the reactants, and our products are at a lower value than the reactants, delta H will equal a negative number. So in an exothermic reaction, delta H will be less than 0. It will be negative. In an equation, we show an exothermic reaction with the energy term to the right of an arrow. So in an exothermic reaction, the sign for delta H is negative. In an exothermic reaction, the energy term is on the right side of an equation. So if we look at this example, we can tell that this reaction is exothermic, and that the value for delta H has to be negative. So even though it looks like it's positive in the equation, the actual value for delta H is a minus 198 kilojoules. In an endothermic reaction, it is a process that absorbs energy from the surroundings. The system gains heat as the surroundings cool down. So here we have our reactant, ammonium nitrate, and it absorbs 27 kilojoules of energy in order to dissolve into these ions in water. If delta H, like we said, is equal to products minus reactants, this time the products are relatively high compared to the reactants, and delta H will be a positive value. So in an endothermic reaction, the sign for delta H is positive. In an endothermic reaction, the energy term is on the left side of the equation. So if we look here, this equation is endothermic, this reaction, because the energy term is left of the arrow, and the value for delta H for an endothermic reaction, it's positive, so positive 198 kilojoules. On the graph on the next page, to the right, go ahead and label each of these reactions as endothermic or exothermic. An endothermic reaction has a positive value. An exothermic reaction has a negative value. So we should have answers that look like mine. And we're going to finish by just taking two of these reactions and writing them with the energy term included in the reaction, not written off on the side. So how about the first one? If we were to write this with the energy term in the equation, since it's exothermic, we would say carbon plus oxygen turns into CO2 by giving off 393.5 kilojoules of energy. We know the energy term is to the right because it's an exothermic reaction, because it has a negative value for delta H. And let's finish with this one. If I were to write this, where the energy term was incorporated into the equation itself, we would say N2 plus O2 plus 66.4 kilojoules of energy will react to form two NO molecules. So the intent of this lesson is to show how you can determine if a reaction is endothermic or endothermic and where the energy term will end up in the balanced equation. So that is it for tonight. We only have a little bit left to do. I'll have a worksheet for you tomorrow on tonight's lecture. And have a great night, and we'll see you tomorrow.